Hi, everyone. Today's lesson is on systems of equations. Systems of equations is where you have more than one equation, could be a conic or a line, and then your equations are intersecting. So we're going to get to that in just a minute. We're going to start off with a warm-up, and so let's get started. Okay, so warm-up. Is it possible for the focal points or the foci of an ellipse to occur outside of the ellipse? The answer to that question would be no. If you have an ellipse, your focal points are always going to be inside the ellipse, okay? And basically that's for your distances and drawing that and all that, but they're always inside. And technically, whether it's a parabola, your focal points are inside. Hyperbola, see how they're inside, but I know that an ellipse is a closed off figure, but the answer is a no. If the vertex and the focus of a parabola are on a horizontal line, so let's see, we have a vertex and a focus point. So let's say there's my focus point here. Here's my vertex. Okay, that works. And the vertex and the focus of a parabola are on a horizontal line. Okay, there you go. Then the directrix is vertical. Well, that would be true. Okay, and so that's true. True or false? The major axis of the ellipse is vertical. So we're looking at this equation right here. They've already completed the square. All we have to do is to set this equal to 1. So I'm going to divide everything out by 36. I'm going to get x plus 2 quantity squared over 4 plus y plus 3 quantity squared over 9 is equal to 1. And if I were to graph this, I would start off at -2, -3. There's that vertex or center. In the x direction, I'm going to go the square root of this value, which is 2. So there's that point and this point. In the y direction, I'm going to go the square root. I'm going to move up vertically the square root of 3. So up 3, down 3. And so this is a ellipse. Looks like my graph looks like this. This distance is 4. This distance is 6. The question is, the major axis is vertical. So yeah, this is the longer axis because this is 3, this is 3. So it is vertical. So that's true. All right. The conjugate axis of a hyperbola is horizontal. So keep in mind, remember, the conjugate axis is the axis that really just connects endpoints. It doesn't connect the vertices. The axis that connects the vertices is the transverse axis. So let's graph this. This is a hyperbola. Again, let's get rid of the 100. So we're going to divide by 100. For this to be in standard form, this value right here needs to be 1. So that's what I'm doing. So we have x minus 1 quantity squared over 100 minus y plus 3 quantity squared over, and this is going to be 100 divided by 25. So that's 4. Is equal to 1. So I see it's a hyperbola. I'm going to graph or sketch it. My vertex is, or center is at 1, -3. So 1, -3. In the x direction, I'm going to go 10. So 10 to the right, 10 to the left. In the y direction, I'm going to go the square root of this value. So I'm going to go 2 up, 2 down. I'm going to make a little box. I'm going to start my hyperbola like this. That's going to go to the corners. And then I'm going to go this way right here, okay? So because my x-axis is positive, my hyperbola is going to go to the right and to the left. It's on the axis that's horizontal, right? And so it looks like that. So this length right here that goes from here to here, that length, that's my transverse axis. My transverse axis is the axis that actually holds the two parabolas, which is make the hyperbolas, okay? So that's my transverse axis. Now, my conjugate axis is this axis right here that really doesn't hold anything. It just touches the endpoints. So that blue line right here, that's the conjugate axis, okay? Whereas the green line here, that's the transverse axis. So it says the conjugate axis is horizontal. That's not true. That's false. The next question says, it's a little bit The directrix of this parabola is, and I think it says 1/2, negative 1/2. So the directrix of the parabola, so what we have here is this equation here. I'm going to rewrite it. I see that I've got x squared minus 4x minus 2y is 0. So I'm going to rewrite that as negative 2y is equal to, I'm going to move this stuff over, negative x squared plus 4x. Okay. I am going to divide everything by negative 1. And in doing that, I now have 2y equals x squared minus 4x. Okay. Now, what's going to happen here is I need to complete the square because I have an x squared and an x. So in doing that, I'm going to get x squared minus 4x. Half of 4 is 2. 2 squared is 4. This is 2y. And then if I added 4 here, I have to do the same thing on the left. So I have 2 times the quantity y plus 2 equals the quantity x minus 2 squared. I'm going to divide by 2, so I get y plus 2 equals 1/2 x minus 2 quantity squared. And the reason that I did that is because my a value, which is this value right here, that's my a value. A is equal to 1 over 4p. And so I'm going to set that equal to 2. I'm going to cross multiply. 4p equals 2. So p is equal to 2 over 4, which is 1/2. So if I were graphing this equation right here, I see that my vertex is going to be at xy. So it's going to be at 2, comma, negative 2. So over 2, negative 2. Now, my graph, if you look at it, it's a y equals x squared. So it's a y equals x squared base graph. So that means it's going to be going up like that. So I know that my graph is going to shoot up like that. All right, now, the question is that the directrix is at y equals negative 1/2. So the thing is for this is if you look at it, there's my vertex, and then my distance here to my directrix is 1/2. So that means I would be going up 1/2. So if this is negative 1, that would mean this is my focus point here. And if I go up 1/2, that's my focus point. If I go down 1/2, that's my directrix, like that. So what that means is the directrix, because it's piercing through the y-axis, is actually going to be y equals 1, 2.5. So negative 2.5. So that would be a false statement. Okay? All right. So this question says, find the equation of the parabola that has a focus point of negative 3, 4. So 1, 2, 3, 1, 2, 3, 4. So there's the focus point. I always put like a little F next to it so it reminds me, this is what it is. The vertex is negative 3, 0. So there's a V. So that means that my graph is actually coming up like this. So that's a y equals x squared graph. Okay? So because it's coming up positive. All right. So that being said, if I have my vertex, I can actually plug this into my equation, right? Because that stems from this equation, y minus k equals a times x minus h quantity squared. So k is 0, so it's like y minus 0 equals a. We haven't done a yet, but we will, times x plus 3 quantity squared. Now a is 1 over 4p. P is the distance from my vertex to my focus. So P is this distance right here. So if this is negative 3, 0, and this is negative 3, 4, that distance is 4. So this would be 1 over 4 times 4, which is 16. So it'd be y minus 0, or just y equals 1 over 16 times the quantity x plus 3 quantity squared. So this is the equation of my parabola. All right. One more parabola problem, and then we'll get to the systems of equations. Find the equation of a parabola that has a vertex of 3, negative 2. Okay, so I'm going to go 3, negative 2. And again, I like to put a V there to remind me that that's what that is. That's my vertex. And it's got an axis of symmetry that's parallel to the x-axis. Now, an axis of symmetry, if you think about it, if this is my parabola like this, then this line in here, right here, that splits my graph like that, the axis of symmetry. If it looked like this, my axis of symmetry would be vertical, okay? So it's not vertical, it says it's horizontal. So now I need to look at that and go and say, okay, well, my axis of symmetry could look like this. Now, if I did that, now it's vertical. Okay, so the next thing you need to realize is that so it's parallel to the x-axis. So that means my graph is either going to do this or it's going to do this, right? Okay, but not at the same time, because then it would be a hyperbola. And I have a y-intercept of 1. So that means that my graph, see there, has a y-intercept of that. So that means that my graph is going to cut across like this. See that? So that's part of because of the y-intercept of being 1. And now, see this? I've got I have a, what is that? Axis of symmetry that's parallel to my x-axis. Okay, so far so good. So we know that this point is 0, 1. We know our vertex point is at 3, -2. So we have enough to come up with an equation. Okay, what I need to figure out though right now is which way is my graph? Is it a y equals x squared? No, that goes up or down if it's a y equals -x squared. So that means that my graph is an x equals y squared. If it was an x equals positive y squared, it would go to the right. But if it's an x equals -x or -y squared, it's going to go to the left. So this is what my graph is going to tentatively look like. And therefore, you're going to do this, and you're going to go x minus h equals negative times the quantity y minus k quantity squared. And so what happens now is that we know hk. This is my h, this is my k. You need to remember that the h is always going to go with the x, and the k is always going to go with the y. All right, so what we have is x minus 3, because that's your x coordinate, equals the opposite of y, and then that's going to be plus 2 quantity squared. But don't forget this, which I almost forgot, but I didn't, the a inside here. So that's negative a. All right, so what that means is a, remember what a is? A is 1 over 4p, which means p is the distance from my vertex to my focus. But realistically, I don't know that because all I have is a point. So I don't know what p-value is. It would be super nice to be able to figure that out. So what I need to do before I figure out this a is I have to ask myself, why did they give me this point right here other than to see what direction it was going? So that's a point that's on my graph, which means that I can plug that into my equation. So I'm going to plug in 0. I get 0 minus 3 equals negative a times the quantity, y is 1, so 1 plus 2 quantity squared. So we have negative 3 is equal to negative a times 3 squared, which is 9. And so negative a is going to equal, what is that? 3 divided by 9 on both sides. So that's going to be what? 1/3? But it has to be negative, you guys, because I know I put the negative in here because that's telling me, hey, this is negative. You see it's going to the left. So just remember to be aware that this value here, even though I'm working this out, it is negative. So that's what goes here. So my final equation is going to be x minus 3 is equal to negative 1/3 times quantity y plus 2 quantity squared. All right, cool. So, I thought that was the last one. We actually have one more parabola question. That's okay. You guys need to work on parabolas anyways. Find the equation of the parabola that has this focus point, which is at negative 3. So 1, 2, 3, and then up 4. 1, 2, 3, 4. So negative 3, 4. And that's my focus point. So I'm going to put an F there, negative 3, 4. And I have a directrix of x equals 7. So over here at 7, I have a directrix, meaning I have a line that goes right through there. That's my directrix. Now, what you do need to remember is that when you have a parabola and a focus point, remember that distance from here to here, that's your p-value. That same distance from here to here is your p-value again. So basically, those are the same distances. So when I'm looking at this, I know that my parabola has to cup inside here, right? It's got to cup my focus like that. Now, what I just need to know is where am I halfway in between here and here? That's what I need to know. Well, if this is 7 and this is 3, that makes a total of 10, right? So that means that I'm over 5. So if I go over 5, so that's a 2. So this point here is going to be 2, comma, how far did I go up? 4, 2, 4. And so my equation, because it's going that way again, remember that's going to give me my negative a. So we have x minus 2 equals, and then I'm going to hold off on a. I'm going to go, this is a times the quantity, x, excuse me, 1 second. A times the quantity, y minus 4 quantity squared. And remember, this value will be negative. I'm just going to leave it as a right now because I do know it will be negative. This distance from here to here we know is 5. So p is equal to 5. The a is equal to 1 over 4p. So if p is equal to 5, I'm going to put 5 over here. So that's going to be 1 over 4 times 5, which is 20. So that value right here is going to go right up there. And so my final equation is x minus 2 equals negative 1 over 20 times the quantity y minus 4 quantity squared. Okay. All right. So finally, we're at systems of equations. So to solve a system that has nonlinear, so meaning basically this is saying that they're not lines, but it is okay to actually have like a conic and a line and trying to figure out where the intersection points are. That's what you're trying to find. We use 2 ways to do it. We use substitution and elimination, but I always make sure that you graph also. Graphing is really important because that means that you can visualize, what you're actually seeing. So again, your job is to substitute or eliminate to solve and to try to find the intersection point. So that's what a system does. And a lot of you did this in geometry and algebra 2, where you tried to find a system of 2 equations. Well, this is a system of 2 equations, but they just happen to not be all linear. So this is just like sketching some possible solutions. So I could have something like this, which is an ellipse and a hyperbola, and I have 4 intersection points. I could have a hyperbola with, let's say, a line, and this line may have 1 or more, if this comes around right, that could have 1 or more intersection points. I could have a circle and an ellipse, 4 intersection points. I could have a parabola and a line, also 2 intersection points. I think one of my favorites is a parabola, but then I have an ellipse, and my ellipse actually only intersects through 2 points. Anyway, you just have to basically graph it. It's very important. So we're going to start off with finding the intersection points between these 2 equations right here. Some of these problems are a lot easier than others, okay? And some of the problems, you're going to be able to see what the intersection point is as soon as you graph it, while others are not going to be as easy, okay? So for this one right here, what you have to be aware of is, what is that? Okay, what is that? That's an ellipse, because these 2 numbers are different. So in that problem, I'm going to go, I'm going to divide through by 36. And in doing that, I'm going to get x squared over 4 plus y squared over 9 is equal to 1. So that's an ellipse. My center is at 0, 0. In the x direction, I'm going to go the square root of 4, which is 2. In the y direction, I'm going to go the square root of 9, which is 3. And I'm going to connect my points because it's an ellipse. This one is a line. I'm going to graph that by solving for y. So 2y equals negative 3x plus 6. Divide through by 2. I get y equals negative 3 halves x plus 3. So for this graph, I'm going to start, that's my y-intercept at 3. There it is right there. I already see an intersection point at 0, 3. Then I'm going to go down 3 over 2. Kind of looks like that's another intersection point to me. So there's my line. Looks like I have an intersection at 2, 0. Not sure, going to check. You're always going to graph. You're always going to check algebraically. So remember what I said on the previous slide. You have two options. You have elimination. That's where you add or subtract to eliminate one of your variables. As you notice on these two equations, if I add or subtract, I can't, if I add or subtract, nothing is going to be eliminated. Whereas if I substitute, I'm going to be able to, I'm going to be able to plug one equation into the other. Excuse me. I love my Starbucks. Anyway, okay, so we have 2y. Oh, I already did that. So I'm going to plug in this equation here for y, all right, into the other equation right here for y. Yeah, I would say to divide everything out, but nothing's going to cancel. So anyway, I'm going to plug that in. So in doing that, I'm going to have 9x squared plus 4y squared, that's y. So that's going to be negative 3 halves x plus 3, quantity squared equals 36. Now this is just algebra. I know it looks awful, but it's just algebra. So we're just going to FOIL that. So we're going to go 9x squared plus 4, and I'm going to multiply that 4 out later. And then I'm going to multiply this inside here. See, this right here is quantity squared. So that's going to be negative 3 halves x plus 3 times negative 3 halves x plus 3. And then I'm going to close that because remember, I still have to multiply by 4. Move the 36 over, and that's equal to 0. Okay, so this is just foiling. You guys know how to do this. So 9x squared plus 4. Now let's do this slow. Negative 3 halves times negative 3 halves is positive 9/4 x. And so that's just the first one right like that. Now you already can see this 4? Those are going to cancel later. Now we're going to go negative 3 halves times 3 is negative 9 halves. And then another negative 9 halves. So what's negative 9 halves and negative 9 halves? So that's negative 18 halves, right? Well, what's negative 18 halves? Negative 9. So that's negative 9x. And then 3 times 3 is 9. And don't forget, minus 36 equals 0. So what we have now, I'm going to multiply that 4 through. So that's going to be plus. Now see, this 4 is going to multiply through. 4 times that is just plus 9x. 4 times that is negative 36x. And 4 times that is positive 36. Don't forget, I'm going to be subtracting that 36. Where these cancel, they're gone. I'm going to combine these two terms right here. And so let's see here. So what I have here, okay, so let me just double check something here. Oh, I know what happened. When I multiply this times this right here, that's just 9/4, right? But that's x times x, so don't forget the x squared like I did. So anyway, so therefore, we're not combining those two terms. We're combining the 9x squared plus the 9x squared, which is 18x squared minus 36x equals 0. So I'm going to take out an 18 and an x. Don't divide anything out because remember, this is quadratic. And if you divide out like 18x, what's going to happen is you're going to lose one of your points. So don't do that. So you have 18 times x, or 18x, and we have x minus 2 is equal to 0. I'm going to split this up. I get x minus 2 equals 0, x equals 2. I get 18x equals 0, and then divide by 18, I get x equals 0. So now what happens here is I realize that I have two values here that I'm going to be plugging back into my equation. So if you could see this way up here, it says y equals negative 3 halves x plus 3, right? So I'm going to plug in 0 in here and also 2 in here. So plugging in 0, I get y is equal to 0 plus 3, which is 3. So one of my intersection points is 0, 3, which we have, check. And then the other intersection point, I'm going to plug in 2. So we go y equals negative 3 halves times 2. So those 2's cancel. And I got negative 3 plus 3 is 0. So y equals 0. So when I plugged in 2, I got 0. So those are my intersection points, which I actually saw in the beginning, but I proved it. So that's what systems of equations is about. And there's a little bit of work involved, but it's completely doable, okay? So let's get started on the next problem. So the next problem says, find the intersection points algebraically and by graphing. So the first equation here is a circle. See the x squared plus y squared. So I know I'm going to go 4 to the right, 4 to the left, 4 up, 4 down. I didn't complete the square, so my center is at 0, 0. This equation, though, is a hyperbola. This is a circle, and this is a hyperbola. So that, because you have a negative square, a negative value here. So what's going to happen is I'm going to rewrite this. So negative 2x squared plus y squared equals 10. I'm going to divide through by 10. I'm going to get negative x squared over 5 plus y squared over 10 is equal to 1. Now, these are the kind of problems that you sometimes aren't going to be able to look really quickly and see. So basically, this is a hyperbola, so I'm going to draw that in. So what I have is my center is at 0, 0. In the x direction, I'm going to go the square root of 5. Well, the square root of 5 is, within here, it's going to be, what, 2 point something. So I'm going to put a point here and here. The square root of 10 is going to be about 3 point something. So I'm going to go 3 something up and down. So remember, this isn't my graph. This is just my box. And then I'm going to put my asymptotes in, okay? This is still not part of my graph. These are not intersection points. These are just asymptotes. And I see that my x squared term is negative, so that means that my graph is actually going to go up and down. So here's my graph. So it's going to go up like that, up like that. It's going to go down and down. So what I actually see are 4 intersection points. My 4 intersection points are 1, 2, 3, and 4. Now, this is where you don't know it's not easy to just see what those values are, okay? So what we're going to do is we're going to solve this algebraically to verify what they are. Remember the 2 ways other than graphing that we're going to solve this? One way that we're going to solve this is either by substitution. The other way is by elimination. And if you were to eliminate, you would want to add or subtract to eliminate one of your variables. So if I were to redraw this, like if I did this, x squared plus y squared equals 16, and I rewrote this, negative 2x squared plus y squared equals 10. And I were to subtract, right, this minus this, my y squareds would be eliminated. So x minus negative 2x makes 3x squared. Y squared minus y squared is 0. 16 minus 10 is 6. I'm going to divide by 3. I'm going to get x squared is equal to 2. And I'm going to square root both sides, and I get x equals the square root of 2, plus or minus. What that means is I'm going to go over the square root of 2. So there's a point here, and there's, not quite a point, but I got to find that point up there. So what that tells me is here for x, I have a positive root 2 and a negative root 2 so far. Okay? We'll put that next to Snoopy. I like Snoopy. All right. So next, I have to take this value of x and I need to plug it back into my other term. So pick one. I'm going to pick the top equation. So the top equation says x squared plus y squared equals 16. All right. So what I'm going to do with that is I'm going to plug that in for x. So the square root of 2 quantity squared, because that's your squared, plus y squared equals 16. Square root of 2 squared is 2. 2 plus y squared equals 16. I get y squared is equal to 14. I have the square root, both sides. I get y equals plus or minus the square root of 14, which means that when I plugged in positive root 2, I got 2 answers. I got a positive and a negative root 14. And when I plug in negative root 2, I'm also going to get a positive and negative root 14, which means that these are my intersection points. This point is root 2, comma, root 14. This point here is negative root 2, comma, root 14. This point right here is root 2, comma, negative root 14. And this intersection point is root 2, comma, negative root 2, negative root 14. Okay, cool. Those are my 4 intersection points. And as you can see in this graph, they're not all going to be, something that you can just look at the graph like the previous one. In the previous equation, we just looked at this and we went, oh, here's my 2 intersection points, done. But you have to prove it. And so that's what the algebra does. They're not all going to be difficult, as the math is not awful. Okay, so this problem right here, this looks like a line. So this is a line. And this one, because these values are different, see that? That's an ellipse. Okay, so I'm gonna divide this out. I'm gonna go x squared divided by 25 plus, this is gonna be y squared over. Now remember, when you divide by 25 like this, see? All right, this right here, you can't have a number in front of the y squared term. So what you're ending up doing is multiplying by the reciprocal, which is the same thing as dividing. So this is gonna be 25 over 4 equals 1. And I know that looks weird, but just deal with it. That's the way it is. And then this is a line, and that's going to be, let's see here, 2y equals negative x plus 7. So y equals negative 1/2 x plus 7 halves. Okay, so let's graph the first problem. The first problem is an ellipse. Center is at 0, 0. In the x direction, remember, in that direction, the x direction, which goes out that way, you're going to graph the square root of 25. So I'm going to go 5 to the right and 5 to the left. For this one right here, I'm going to go the square root of 25 over 4 in both directions, which is the y. So I'm going to go 5 halves up and down, which means that, what is that, 2.5. So up 2.5 and down 2.5. And this is an ellipse. Connect your dots. Here we go. This is a line, and this line is going to start at 3 1/2. So we're going to go up 3 1/2. And then that means I got to go down 1 over 2, down 1 over 2. So I'm not really sure where my graph is going to cross, but it looks like it might be crossing in 2 places over here. I'm going to move this a little bit so you can see better that looks like it's, I'm not sure where it is because the graph is a little bit off, but we're going to find out in just a second. Okay. So in order to find out algebraically, okay, I'm going to erase that so I can see. So this one, I'm actually going to plug into the other equation. Now, see how I solved this for y already? That's really great. Use your common sense, though. Do I want to actually plug that into this right here? Or do I want to solve this equation for x, like this? X equals negative 2y plus 7, so there's x. And then plug x into that. See, that's way better. Well, I mean, not better. It's just different because I don't have to deal with the fractions. So that's your choice, of course. And so you just choose how you want to do that. So I'm going to plug it into x. So we're going to go x squared. So that's going to be negative 2y plus 7, quantity squared, plus 4y squared equals 25. So I made that too small. I can't see that. Okay, so now multiplying this out, negative 2y plus 7 times negative 2y plus 7 plus 4y squared minus 25 equals 0. So I've got 4y squared minus 14 minus 14y makes minus 28y plus 49 plus 4y squared minus 25 equals 0. And if you notice, my y squareds are going to be added together, so I can add those together. And so I have, what do I have? 4 and 4 is 8, so I have 8y squared, so those are gone. Minus 28y, that's gone. And then 49 minus 25 is 24, so plus 24 equals 0. Now, I'm just going to divide by 4 on everything so that the numbers are a little bit smaller. So that's going to make y squared, 2y squared, minus 7y plus 6 equals 0. And I'm going to factor that. I'm going to get 2y let's see, they both have to be minus. So 2y times y equals 0. I'm trying to make -7, so 3 and 2, that's not going to work. -3 minus 2, let's see. -3 and -4, woohoo, okay, that worked. Split these up, you're going to get y minus 2 equals 0. And so y is equal to 2. You have 2y minus 3 equals 0, so 2y equals 3. Y equals 3 halves. So I have 2y values. So what that means is this. So I'm going to actually put these aside. So here, see, there's my values here, my 2 points. And so I've got one of my y's is 2. See right there from that. My other y is 3 halves. Notice I'm putting them on the y side. Okay, now I got to plug that in. Pick an equation. I'm going to use this one. This looks like a happy equation. Plug in 2 for y. So if I did that, I'm going to get, I'll do it down here. Plug in 2 for y. X equals -2 times 2 plus 7. So that's what? -4 plus 7 is 3. So one of my intersection points is over 3 up 2. That looks like that point right there, 3, 2. And then my other intersection point, I'm going to plug in 3 halves. So let's see, let's do this again. X equals -2, and I'm plugging it in way up here. So -2 times y, what's y? 3 halves plus 7. 2's cancel. I get -3, add 7, 4. So 4, 1.5. So there's my 4, 3 halves, or 1.5. All right, cool. So yeah, that was, I mean, not difficult, but you just have a lot of different things going on. So anyway, so for this problem right here, what I just want you to do is, what if you were asked to solve the following system? What method would you choose? Don't solve the system, just discuss what you would do. And I would hope that when you're solving the system, that you would, you have 2 options. And I want to talk to you about that. Obviously, well, I guess maybe it's not completely obvious, but I would think that most people would take y squared equals and plug it in here. And you would go x squared plus your y squared, which is this, x plus 5 equals 25. Oh, it's quadratic. I need to set it equal to 0 and then factor. But I want to talk to you about some people may not do that. And some people may go, I really like subtracting method, the elimination. So if I did that, I would go x squared plus y squared equals 25. And then I would move this x over to the left. And then I would have a -x plus y squared equals 5. And I'm not saying you can't eliminate. What I'm saying is you can, but one way is just a little bit easier than the other. Let me show you what I'm talking about, because to get my y's eliminated, I would subtract. But then you see these don't disappear. What you end up having is x squared minus negative, so plus x. Y squareds cancel. 25 minus 5 is 20. And I'm going to actually get, see that, if I had substituted, if I had continued this, plus x, subtract this, and I get minus 20 is 0. I'm going to get this same thing, plus x minus 20 equals 0, and then factor, solve, etc. Just saying, you have options. Either way would work. I just want you to be aware that there are other ways, multiple ways to do that. Solve the following nonlinear system. So this one is a circle parabola. Oh, very cool. Let's see. So the first one, we do need to complete the square to solve that. So to complete the square here, I'm going to group, oh, that's already grouped for me. So x squared plus y squared plus 2y, half of 2 is 1, 1 squared is 1. Remember, if I added 1 to this by completing the square, I do need to add 1 on this side. So I have x squared plus this right here, which is y plus 1 quantity squared equals 4. Now, I just want to point out that I only had to complete the square 1 time, because see how I have an x squared? If I don't have an x that goes along with that, you're not completing anything. Whereas see how I have a y squared and a y? I'm completing the square. So I have to finish that. So that's why I only completed this square 1 time. Anyway, my center is at 0, -1. So 0, -1. This is my radius. So if this is equal to radius squared, r is equal to plus or minus 2. So I'm going to go up 2, left 2, right 2, down 2. So now I have a circle. This, though, is a parabola. And for this equation, let's graph that. So let's see. I like the x squareds and the squareds on the right, so I'm going to rewrite this. So we got negative y is equal to negative x plus 5. I don't like that there. So I'm going to move that 5 over. And that's going to be, oh, did I lose my x squared? There we go. Actually, I'm just going to divide by negative 1 first. So I have y equals x squared plus 5. Oh. Well, you guys know that y equals x squared looks like this, right? And if you add 5, that's going to bring that up here. So that looks like my parabola looks something like this. And if that's the case, there's actually no intersection point. So this would be no solution because there's no intersection. But let me just make sure. Let me rewrite this. So negative y equals negative x squared plus 5. Divide by negative 1. Y equals x squared minus 5. Oh boy. So that was just making sure that's not right. So if that's negative x squared minus 5, that parabola does this. So minus 5. So this is a x squared. This is my parabola right here at y equals x squared. So if I were to subtract 5, watch what's going to happen. It's going to go down 5. So where are my intersection points? That's what I want to know. It kind of looks like they're right there. And so if that's the case, okay, so now I need to prove it. We're going to prove it. So I'm going to start with my original equation, okay, which was this right here. And I'm going to plug this in. I'm going to substitute, which means that I would go x squared equals y plus 5. And so don't square root that because, see, this is already x squared. You don't have to square root it. It's exactly the same. So we're going to go y plus 5 y plus 5 plus y squared plus 2y equals 3. So let's see here. I have y squared plus 3y. I'm going to subtract 3 from both sides, and I get plus 2 is 0. I get y plus 1 times y plus 2 is equal to 0. Split this up, I get y is equal to negative 1, and I get y is equal to negative 2. And so that means that my y values are going to be negative 1 and negative 2. So from there, I got to plug back into my equation, those two values. So pick one you want. I'm going to pick the second one right here. And so plugging in y, let's see here. If x squared is equal to y plus 5, y is negative 1. So negative 1 plus 5 is 4. Square root of that, so I get x squared equals 4. So x equals plus or minus 2. Oh, so we have 2 here, plus or minus 2. If I plug in negative 2 plus 3 or plus 5, I get x equals plus or minus the square root of 3. So for this problem right here, I actually have 4 intersection points, which means that this green graph here is not accurate, which is why you want to definitely always check your answers. But my green graph, it looks like if I just move this over just a little, it's too fat. So let me delete that and redraw it. So to me, it does look like my graph is going to look something like that. And so you're going to have to solve the equations algebraically in order to see, where your intersection points are. Always prove it. Because as you can see the graph, my original graph, I think my parabola was just too wide. And you don't know, right, unless you actually graph what the parabola is going to look like until you do that. So always a good idea to graph. So we have this last problem right here where we have 9x squared plus 5y squared is 45. This is an ellipse. I'm going to divide through by 45. And in doing that, I get x squared over 5 plus y squared over 9 equals 1. So this is an ellipse. Center is at 0, 0. In the x direction, I go the square root of 5. which is going to be 2 point something left and right. On the y, I'm going to go 3 up, 3 down. I'm going to make my ellipse. Okay, almost looks like a circle. Sorry about that. This is a hyperbola. I'm going to divide by 54. I'm going to get y squared over 9 minus, this is going to be x squared over 2 equals 1. And my center is at 0, 0. In the x direction, I'm going to go the square root of 2. In the y direction, I'm going the square root of 9. And so what that tells me is I've got a box. I do kind of see some intersection points here, but remember that I don't know if those are my vertices or not, so we'll have to check. And let's put our asymptotes in like this, right? And then we're going to make our graph. And our graph, because y squared is positive, my graph does go up like this. And it does go down like this. And very clearly, I see that my two intersection points are 0, 3 and 0, -3. Now, some of these problems are a lot more clear than the others, obviously. However, I still think you should always, check your answers by graphing and solving the system. So, you want to do that? Let's solve the system. What I would do is plug in one equation. Actually, I wouldn't. I think in this problem right here, I might multiply these out. Like I might say, well, 9, if I eliminate, let's say, my x squared. So let me rewrite this. So we've got 9x squared plus 5y squared equals 45. And then I've got -27x squared plus 6y squared equals 54. If I wanted to solve this problem by elimination, I would multiply this first part by 3. And then I would rewrite that to be 27x squared plus 15y squared is equal to 3 times 45. What is that? 135? 135. And then this is going to be -27x squared plus 6y squared equals 54. And if I were to add these two equations, these cancel. I get 15 plus 6, which is 21y squared. And what's that? 189. I'm hoping that 189 divided by 21 works. So let's check that out. 189 divided by 21. Let's see. You probably got this down faster than me. 189 divided by 21 is 9. Yay! And so therefore, we're going to square root both sides, and we get y equals plus or minus 3, which we kind of already knew, right? 3 here, negative. Okay. And that when I plug my equation back into one of the original problems, I'm hoping that I get 0 because that's my x values. So let's just try one of these. We're going to go 9x squared plus 5 times 3 squared is equal to 45. 9, this is 9, right? 9 times 5 is 45. So I have 9x squared plus 45 minus 45 equals 0. 9x squared equals 0. X squared equals 0. X equals 0. Okay, so we have our intersection point. So that's what the systems of equations is all about. So I hope that helps, and thanks for watching.